So let's look at another example involving surface area here. So let's find the area of the portion of the surface. F of xy will be 1 minus x squared plus y. That lies above the triangular region with vertices 1, 0, 0, 0, negative 1, 0, and 0, 1, 0. All right, so if you notice, all of these points lie on the xy plane. So let's just draw this triangular region in the xy plane. So let's plot these points. So we get 1, 0, 0, negative 1. Maybe I'll draw this a little bit lower here. And 0, 1. So this is my triangular region. And I need to describe this region. So if I look here, let's focus on it going up and down. And then I start with x. X is between 0 and 1. And then y. So this bottom function, the slope would be positive 1. So this bottom one would be y equals x minus 1. And this top line has slope negative 1, so y equals 1 minus x. So y is between those two. And then we're going to need to take our function f of xy, which was 1 minus x squared plus y, and we're going to need to find the partial derivatives of that function. So fx, it would be negative 2x, and fy would be 1. So then when I plug these into my surface area formula, the integral of the region of r, square root 1 plus negative 2x squared plus 1 squared. So you're getting s, it's the double integral over r, the square root of 2 plus 4x squared. And now we're going to use our description of r, goes from 0 to 1, x minus 1 to 1 minus x, dy dx. Now notice that there's no y here in our function. So when I integrate with respect to y, I'll be getting this square root times y so this becomes the integral from 0 to 1, the square root, so it'll be 1 minus x times the square root minus an x minus 1 times the square root and if you distribute this minus here, make this plus a negative and a positive, you'll see that you can now combine these as 2 times the square root of 2 plus 4x squared minus 2x times the square root of 4x squared plus 2. And then you can split these up into 2 separate integrals. So for this second integral, you can use substitution. For this integral, though, you're going to need to use trig substitution. So I'm going to skip over it, but you should review trig substitution here. So when you do trig sub on this first one, you'll get x times the square root of 2 plus 4x squared plus ln of 2x plus the square root of 2 plus 4x. When you do a u sub on the second integral, you're going to get, so there's a minus 2 plus 4x squared to the 3/2 over 6. And then you're going to plug in top number minus bottom number. So you'll get square root of 6 plus ln 2 plus square root of 6 minus square root of 6 minus ln of square root of 2 plus 1/3 square root of 2. And you can just leave your answer like that. It's not pretty, but that would be your answer here.